last central interpolation formula that we are going to discuss is a Bessel central interpolation formula. Now, this one is a very interesting why we use the Bessel central interpolation formula. We have a Gauss forward, Gauss backward and Stirling formula. The Bessel central interpolation formula is give the more accurate value if we have initially even number of a data. Even number of a data means Bessel's interpolation formula applicable if initially means the initial data, the given data have a even number of terms. So, similar to the Stirling interpolation formula, Bessel's formula also applicable if the values of a u lie between -1/2 to 1/2, but there is some a special situation, a specific formula means a special case. If u is a 1/2, then the Bessel's formula always use the even order forward differences, even order forward differences. So, what will happen in a Bessel's interpolation formula? Just we once explain the Bessel's central interpolation formula. Here we already write for sake of simplicity the Bessel's interpolation formula, but if we have a values of a what? If we have a values of a x and y, and here we have a values of a x0 minus h, x0 plus x. If we have a values of x means the values of x0, this one is x0 minus h, x0 plus h, and here we have a values of x0 minus 2h, sorry, not x0 plus h, x0 plus h, and x0 plus 2h, x0 plus 3h. Suppose initially we have a even number of a data, even number of a data. This one is a 0, minus 1, minus 2, 1, 2, 3. Here this one is a y0, y minus 1, y minus 2, y1, y2, y3. Obviously, first order difference with a del y. This one is a del y minus 2, del y minus 1, del y0, del y1, del y2. So, initially if we have a even number of terms, so which value we are going to use? In a Stirling formula, initially we choose any one value. Suppose we choose the y0, so y0 is not a central value. So, in a Bessel's formula we use initially these two value, average of these two value, then we use the central value. Central value here, because here how many number of central values? Here this one is a central value, central value. So, only difference between Stirling and Bessel's formula, Stirling formula applicable if initially we have an odd number of a term, a Bessel's formula applicable if initially there is a even number of a term. In both the formulae, u must lie between -1/2 to 1/2. For sake of a simplicity, here already we write what? Bessel's interpolation formula. This one is a Bessel's interpolation formula. Already we write a Bessel's interpolation formula. This one is a Bessel's interpolation formula. Bessel's interpolation formula. So, here we write a Bessel's interpolation formula. Interpolation formula. Bessel's interpolation formula. This one is a Bessel's interpolation formula. Bessel's interpolation formula. So, if we closely observe the Bessel's interpolation formula, as we earlier explained, this one is if there is a even number of a term, first term is a average of a two middle term, and here we use the first order difference. In a first order difference we use the middle term. Second order difference we use the average of two middle terms. and in odd order we use the middle term, or you may say in a Stirling formula, here we use a y0, then average of what? Del y0 and del y minus 1, and then del to y0 like this one. Means if odd number of a term, then we use the Stirling formula. If even number of a term, then we use the Bessel's interpolation formula. And if we closely observe the Bessel's interpolation formula, if we put u equal to 1 by 2, because u must lie between what? Minus 1 by 2 to 1 by 2. 1 by 2. So, if u equal to 1 by 2, then what will happen? What will happen? This term becomes 0, and this term also become 0. This term also becomes 0. Means in a Bessel's formula, if u equal 1 by 2, then this may be treated as a special case, and only we use the what? Only we use the even number of forward differences. The odd difference term become 0, because there is a multiple of a u minus 1 by 2, u minus 1 by 2. So, if we put u equal 1 by 2, then this term means the forward differences with odd order terms become 0. Okay, because there is a multiple of a u to power minus 1 by 2 with del y0, u to power minus 1 by 2 with del 3y minus 1, del 5y minus 2, and so on. So, this one is a what? This one is a special case of a Bessel's interpolation formula. Now, we are going to solve one numerical problem based on a Bessel's interpolation formula. So, what is the problem? Using Bessel's interpolation formula, find the value of y35 from the following table. So, what is the data? Data is a x equal 20. At x equal 20, what is the value of a y? Y is a 512. At x equal 30, y is a 439. At x equal 40, y is a 346, and x equal 50, y is a 243. So, first we write a Bessel's interpolation formula. Before writing the Bessel's interpolation formula, just we try to find out the value for u. U equal x minus x0 upon h. X minus x0 upon h. So, what is the u? U is a 35. So, here x, not a u, is a 35. Basically, here x is a 35. So, here we write a 35, and if we choose x0 with a 30, if we choose this one is x0, then 35 minus 30 divided by what is the difference between first data and second data? This one is a 10, then this one is a 1 by 2. U become 1 by 2. So, if u lie between minus 1 by 2 to 1 by 2, then obviously be able to apply the Bessel's interpolation formula. And how many number of a term initially we have? We have initially even number of a term 1, 2, 3, 4, even number of a term. So, we are not going to apply the Stirling formula, we are going to apply the Bessel's formula, because initially there are even number of a terms and the value of a u lie between minus 1 by 2 to 1 by 2, and in this case we luckily find what? We luckily find the value of a u is a 1 by 2, means we are not going to use the odd order forward differences. We are going to use only a even order forward differences. So, by choosing this x0, we are going to construct the difference table. In order to save the time, already we construct the difference table. So, here we choose this one is x0, this one is x0, then obviously this one is a x1, this one is a x2, and this one is a x minus 1, this one is a u equal to 0, this one is a minus 1, this one is a plus 1, this one is a plus 2, and this one is a what? This one is a y minus 1, this one is a y minus 1, this one is a y0, y0, this one is a y1, this one is a y2, this one, this one. What is the first order difference? First order, this one is a del y minus 1, del y minus 1 equal to this one, del y 0 equal to this one, and this one is a del y 1 equal to this one. This is a del 2 y minus 1, this one is a del 2 y 0, and this one is a del 3 y minus 1. And luckily we able to find out here what is the value for u. U is a 1 by 2. So just we write these values here, y0 plus y1 by 2. So here we write a what? We write a, now we write a, here we write a Gauss, sorry, not a Bessel's interpolation formula. Now we write a Bessel's interpolation formula. Bessel's interpolation formula. So what is the Bessel's interpolation formula? Already we write the Bessel's interpolation formula. What is the Bessel's interpolation formula? Bessel's interpolation formula is what? Y equal y0 plus y1 by 2. This one is the first term, plus u minus 1 by 2 and del y. What is the formula? Formula already we write. This one is a del y0. Del y0 plus u minus 1 upon factorial 2 and average of a what? Average of a del 2y0 and del 2y minus 1. Average of a del 2y0 plus del 2y minus 1 divided by 2. This one. U minus 1 upon factorial 2 del 2y0 plus del 2y minus 1 divided by 2. This one is a third term. And what is the fourth term? Fourth term is a u minus 1 by 2, u minus 1 upon factorial 3, and this one is what? Del 3 y minus 1 plus how many number of terms is needed in this question, because there is up to a third order forward difference. So there is no need to write a formula after the third order forward differences. So already we write here what? Already we write up to a third order forward differences. But luckily, what is the value for u? U is a 1 by 2. So what will happen? This term become 0, and this term also becomes 0. This term also become 0. So what is the value for y? Now y become y equal y0 plus y1 by 2. So what is the y0? Just we write the value for y0. Y0 is a what? Y0 is a 439 and 346. Y0 is a 439, Y1 is a 346. So just we put the values of Y0. Y0 just we write here. Y0 is a what? Y0 is a 439. Just erase out this one. So just put the value of y. Y become what? Y0 is a 349. 349 plus, sorry, not 349, 439. sorry, this one is a 439 plus, what is the y1? y1 is a 346. 346 divided by 2. There is no need to calculate the first next term, because u minus 1 by 2, the value of a u is a 1 by 2, so this becomes 0. Next term is a u is a 1 by 2, so 1 by 2 minus 1 divided by factorial 2 del 2 y0 and del 2 y minus 1. So what is the del 2 y0? Minus 20 and minus 10. So here we write minus 20 minus 10 divided by 2, and there is no need to write a next term because there is a odd order differences. So here there is a multiple of a u to power minus u minus 1 by 2, so this term becomes 0. So after simplification of this result, after simplification of a first term, we get what? We get 392.5, and simplification of a third term 1.875, because second term and fourth term become 0. So what is the final result? Final result is a y equal 394.375. So what is the summary of a Bessel's interpolation formula? Means how we apply the Bessel's interpolation formula to solve any numerical problem. First of all, if this one is a given, you apply the Bessel's interpolation formula, then there is no any option. But if there is a given, use the suitable interpolation formula. If there is a even number of a term initially, and we choose the x0 in such a way the u lie between minus 1 by 2 to 1 by 2, then we apply the Bessel's interpolation formula. If this one is already given, means apply the Bessel's interpolation formula to find out any unknown central values, then we choose the x0 in such a way the value of a u lie between minus 1 by 2 to 1 by 2, then write Bessel's interpolation formula and construct the difference table, and in a difference table identify the values of a y0, y minus 1 and del y0, del 2, del y minus 1 means the central values and average of a central values, and use these values in a Bessel's interpolation formula, and after simplification we get the result. I hope you enjoy the lectures of our central interpolation formula. Thank you very much joining my lecture. Thank you very much.